Sofar Solar academic training class. This is Mr. Zhang, the technical engineer from Sofar Solar. It's my honor to sit here, share Sofar Solar products with you. And the topic today is Sofar Solar Star product, 5 to 20 kilowatt, 3-phase hybrid inverter. Because of time limiting, all the questions I will answer at the end of this meeting. And you can also send me your question to email service@sofarsolar.com. Okay, let's start it. Today, we will talk about 3-phase hybrid inverter through those aspects. The features. As Sofar traditional, we offer 4-inch LED screen to you. Through the screen, we can see many useful information, and we can get from the screen many different details. And for MPPT tracker, we can support 1.5 times overload. For the battery, we can accept the range from 180 to 800 volts. And the battery discharge efficiency will reach 97.8. And it's very flexible to change between different modes, from grid type to grid off. And we have 2 streams of the battery. Each stream we have maximum current is 25 amps, so totally is 50 amps. And we support the unbalanced load, both on-grid and off-grid mode. But for on-grid mode, we have to remember we have to enable the power limited function. Otherwise, just like a normal on-grid, it will not support unbalance. Okay, let's talk about interface. Position 1 is the battery terminal. Position 2 and 3 is for the panel input. Position 2 is the DC switch for panels, and position 3 is input channel for the panels. Position 5 and position 4 is for AC parts. Position 4 is for load connection. Position 5 is for grid connection. If you want to use in the off-grid mode, please remember all the load have to be connected in position 4. Position 6 is the USB and Wi-Fi. It shares one port. So if you want to make some change through the USB, remember, take out the Wi-Fi first. Position 7, this is for DRMS, just the logic interface. And the position 8 is very important, it's the control. If we want to communication with battery, also communication with meters, we have to make those cables connected in this position. The position 9 and 10 used for the parallel connected. Just if you want to have couple inverter connected together to get together a big system, you can use this port. And the position 11 is for CT. Please remember, Sofar offer free meter for most of 3-phase hybrid inverter. If you want to use CT, you have to mention with our sales manager first that you need a CT, not meters. Otherwise, we offer the meters. And this is the parameter for our inverters. As I know, most of them already read the Sofar Solar data logger, data sheet. So I just mentioned something very important. First, the number of the stream per MPPT tracker. For 5 kilowatt, 6 kilowatt, 8 kilowatt, we just have 1 stream per MPPT. And for 10 kilowatt, 15 kilowatt, 20 kilowatt, we have 2 streams per MPPT, so totally 4 streams. Also the battery input for 5, 6, also the 8. We just offer only 1 battery input. So this is the maximum charge, and the discharge current is 25 amps. And for 10, 15, and 20, we offer 2 battery terminals. So totally, the charge and discharge current can reach 50 amps because we have 2 strings. Each string is 25. And the communication interface with battery is CAN. Some of the battery we can communication through RS485. The AC output data. We can have the maximum output to unity grid is 5.5 VA. So this is apparent power, and this is the active power. So most of the question customer just asking about what is the nominal AC power, what is the maximum AC power. And we can see also the backup for the inverters. The backup nominal is 5, and the maximum is 5.5. It's the same with the on-grid. This is the protection we have. We have DC switch, and we have PV reverse polarity protection, output over current protection, output over voltage protection, anti-slanting, resistor protection, insulation resistor protection, surge protection is level 2, and the battery reverse protection we also have it. And we also have some feature. The DC terminal we're using is MC4, and the monitoring we offer Bluetooth, RS485, Wi-Fi. Also we have GPS, and Ethernet is optional. Okay, this is the system diagram. Normally, a system just construction like this. We have PV panels, battery, critical load, normal load, also the smart meter testing how many power export or import from grid. And this is the electrical connections. So electrical connection shows the details, connection of AC side of the critical load, normal load, also the cities, and we mark the size of the different components. Startup procedures. First, making sure there is no electrical energy in the system. Just making sure if you have other inverter or other like battery input or something go to grid, we have to turn it off before we start our inverter. And the step 2 is turn on the DC switch. After we turn on the DC switch, we have turn on the battery. Normally we have DC oscillator between battery and the inverter, making sure we have to turn it on also at the same time. Then we have to turn on the grid. Then it's a load. After that, inverter will start. For our hybrid inverter, we have make some selection before we go into the system. First is the language. The default setting is English. If you can find some other option and it's your own language, choosing your own language. For me, I'm Chinese, maybe I can choose the language of Chinese. Step 2 is set the inverter time. Step 3, safety parameters. Normally, so far, we are offer you the safety document through the USB. So please remember with the USB, also the safety parameter document from so far, because we have made some selection that different country code, different policy, different standards through the USB. After that, we have to selection the input channel. We have totally 4 channels for battery and the solar. So I will make an introduction later. Step 5, set the battery parameters. If you are using the lithium battery, just choosing the battery type. If you are using the lead acid, please remember you have to set like current limited or voltage limited for your batteries, and then all the setup is complete. So you can see here, input channel configuration. We have totally 4. Battery, we have 2 input. PV, we have 2 input. If you just only have 1 battery, making sure put on battery input 1 and battery channel 12 set to do not use. The same, if you just only 1 string of PV input, just choosing PV input 1 and set PV input 2 do not use. For our inverter, we have several different working mode. First, self-using mode. We have totally 4 parts: panels, battery, grid, and load. So we have different priority. Grid is first, battery is second, and the grid is the third. Because for the PV panels, it always generated power, not taking any power. So don't care about this. If PV generation equal to load, the inverter will charge or discharge battery because you can see 3.5 kilowatt from the panels and also 3.5 of the load. So no power to battery and no power to grid. Either we are using for grid first because the load is the biggest. Second, if PV generation larger than load consumption, the power will go to the battery first. At this sample, we have 3.5 from the panel and the load just take 1.48. Battery is not full, so the power from the solar using for load first and the extra will charge to the battery. But for this, battery is full, cannot take too much power. So the power we're using for load first, charging the battery, because battery now is full, can only take 2.4 kilowatt. Because as you know, our battery maximum can take not only this value, so the extra power will export to grids. But if your load is really heavy, the solar power cannot support your load separate. We have to working together. The panels and the battery will all charge to your to the load. But if your load is too big, the panel and the battery work together cannot support it. We need to take some power from grids. So the power supply polarity level is PV power bigger than battery, bigger than load. And the power consumption polarity load first, battery is second, the last option is the grid. And for some country, maybe the power company cannot allow X power to grid. So we have to enable the anti-reflex control and making sure CT or meter is in right position, and then we can limit the power export to grid to reach your request. Time of use mode. Time of use mode just like a situation. As you know, power we are using for load first. But if your load is really big during the daytime, your solar power cannot support to your load. So your battery always empty. So for this situation, we can just change the working mode to time of using mode. enable these roles, and then selection a time to charge the battery. Maybe we can choose in the charging time in the evening because different price for different time zone. The electricity price is different, so we can make sure our battery is always full. So just make our battery much more better and more health. Timing mode. Timing mode, we using during the testing. Just check the charge or discharge is working or not. We can set a time, start charge, or end of charge, and set the charging power to see the charge and discharging function is good or not. Passive mode. Using PC app to send a commander to inverter to program a special mode. As you know, our inverter communication with the computer or with some other device by using the RS485 portal. We can follow this portal, write our own program. Using this program, just control our inverter to charge or discharge. Give a commander, then it charge immediately. If you want to discharge, send another commander. So this is the passive mode. EPS mode. EPS, what is the EPS? Emergency power supply. So if PV generation, then the load. Also, the extra power will move to the battery. And if PV power equal to the load, no any power to battery, and the battery just stand by, no charging or discharge. And if PV generation less than load, both panels and the battery will working together to support the load. And if the PV generation is good and the load consumption is zero, the power will all storage to battery, but making sure it cannot storage too much power if the battery is full. Application mode. Okay, this is typical energy storage mode. This is the system we always did, and this is the typical one. So everything is here, just like a normal construction by panels, batteries, critical load, normal load, and smart meters. But if we missing some components, what should we do? First, system without the PV connection. Our hybrid inverter just working like a battery charge or discharge controller. It can import or export power from the grid, charge the battery, and when grid is lost, maybe working like a backup. So it means the panels is not very necessary, but it is better to have PV panels because we have these functions. Panel power, the solar power is very important for this system. Second, without battery. If we're working without battery, the hybrid inverter just working as on-grid inverters. Second, backup mode. If we do not have grid, both panel and the battery will working together to support your critical load. It's critical load, not normal load. System with multiple inverters. As I mentioned, we can have many inverter connection in parallel. The maximum we can have is 10 inverters. 10 inverter working together have its own PV panels and own batteries. it will working together like one system. We can have one master, other are slavers, just working together. Together a big storage system. At this moment, the maximum we can have is 10 kilowatt connection in parallel. So remember, maximum is 10. AC root system. If you're familiar with sofar, you can know that we have a production called Emery 3000 SP, an AC copper inverter. Also, our three-phase hybrid can have the same function also. Because you already have a grid-tied inverters, so we have to set a meter here and a meter on this position. So our hybrid inverter can know how many power generated by your own grid inverter, how many power generated by my hybrid inverter. So it's working together to let the AC use the systems. We can, for this system, the most benefit, we can have more panels. Some benefit is the grid type. For this situation, we're always using for the grid type solar system already existing. More capacity of the power is needed. Battery is needed for emergency, and no extra space for solar panels because this just working as a battery charge and discharge controller. No solar power here. But you still want to change your three-phase on-grid system to hybrid system, you can do it also. The backup unbalanced output, you can see here. You can see here, just the circuit breaker is a single phase. The critical load of forces is in three phase and unbalanced. You can see here, right? We can have 1 kilowatt for phase 1, 3 kilowatt for phase 2, and 5 kilowatt for the phase 3. It can support the unbalanced load. And on-grid unbalanced load. But for this situation, you have to make sure this is used only for anti-reflex power is enabled. Your power company cannot allow you export power to grid. Otherwise, it's very easy. Just it's a normal load. Different phases have different power of the load. It's okay. But if you power company do not allow you X power to grid, you have to enable the power limited functions. For our three-phase hybrid, it can support the unbalanced load also. For example, 1 kilowatt here, 3 kilowatt here, 5 kilowatt here. So PV panel and the battery will working together support totally 80 kilowatts. And if you still have some extra power here, it will charge to the battery first. Monitoring. Multiple function remote monitoring is very helpful for us to check our system working normal on load, and it is very helpful for us to do the service. For example, we can just do remotely control or remotely firmware upgrade to our inverters, and we can debug the issues through the monitoring. So the monitoring is very important. User can the data from inverter will go through the router and through the internet. Also, the user can check it through our app or our laptop. This is the interface of our apps. Here is the construction, the same with our screen. How many power generated from solar, how many power charged or discharged to the battery, and from grid side, we taking power or export power. So we got the value from these three sides, we can identify how many power to load. And we have many different integrators, like how many power daily energy charge, or just we have different value for different this component is for the grid. We can know how many power we're taking or export from grid, and for battery charge or discharge from battery. So we can use that. From this, we can know how many power from solar is self-using, or we just taking from other place. Daily consumption is monthly, yearly, or totally. And this is the flow chart. We can know how power goes. For this example, we have 4.95 kilowatts from panel, and because the load is really heavy, so no extra power to battery, so battery shows 0, and we still need a 1.55 kilowatt from grid working together to the consumption, because at least component battery seems very empty, cannot do any discharge. And this is for the graph. We can see here how many daily production from solar power, the percentage of the self-use, and how many daily consumptions, also the reductions. And this is the graph, so different values. Advantage function. So the backup automatic switch just the time change from on-grid and off-grid mode. At this moment is 20 ms. And we have the remote upgrade functions. Just as you know, we can change your software vision remotely and make some change of the setting remotely. And we support some monitoring situation, for example, Wi-Fi, GPRS, RS485, also the Bluetooth. We support the unbalanced anti-reflex functions. And it's compatible with multiple brand lithium batteries, also the lead-acid batteries. We have every current, and it can help to make sure the power generation as stronger as they can. Without the remotely firmware upgrade, we can also support the local firmware upgrade. It has to complete with the USB. And if you need it, contact Sofar Solar technical support, and we can offer to you. Multiple application modes suitable for very aware. As I said, just like a different working mode, you can just like different application without panel, without the battery. Also, you can parallel more inverter together a big system. All this function is all this function we have it for our inverters. Application sales rates. The HYD sales phase emergency storage have competitive from system complete from 5 to 20, because as you know, it's 5 to 20 kilowatt inverter, and we can have maximum 10 kilowatt connection in parallel. So it's 5 to 20 kilowatt for one dependent energy storage system. So it can be applied in various scenarios which is uninterface or independent power supply. To to cut just working like a backup. A supermarket, hotel, factory, school, or hospital farm, mostly like this. If you still have any question, you can contact us through the email to info@sofarsolar.com or service@sofarsolar.com. And thank you for your joining our training class today. Hope to see you soon. Thank you. Bye-bye.